Look at your immediate surroundings: the chair you're sitting on, the air you're breathing, the screen you're watching. Since early times, humans have tried to categorize this environment. Early Indian philosophers divided the universe into 5 basic elements: earth, air, fire, sky, and water, a system they called the punchadva. Modern scientists refined this concept, defining matter as anything that occupies space and has mass. But for centuries, a debate raged regarding its actual nature. Is a solid object continuous, like a block of wood, or is it made up of tiny, individual pieces, like sand? We can see the answer by looking at this diagram of a simple beaker of water. When you dissolve salt into it, the overall water level does not rise. The salt doesn't push the water out of the way. Instead, its particles slide perfectly into specific gaps that already exist between the water molecules. This proves that the solid, continuous world we trust with our eyes is a macro-level illusion. Beneath the surface, our reality is highly porous and microscopic. To understand this reality, we have to look at the scale of these particles. Watch what happens when a single crystal of potassium permanganate hits a pool of water. One tiny piece fractures into a rapidly expanding cloud of millions of pieces, each one continuously dividing. They are small beyond our imagination. Their behavior is dictated by 3 strict rules. The first rule: no matter how dense or heavy an object appears, there is always measurable empty space between its constituent particles. The second rule: these particles are restless. They possess kinetic energy, meaning they are in a state of constant motion. If you light an incense stick in the corner of a room, the scent particles radiate outward, colliding with and slipping past ambient air molecules to actively fill the empty space, a process known as diffusion. The third rule: particles exert an invisible attractive force on one another. They hold on to each other like a human chain, though the strength of this grip varies drastically depending on the specific substance. Every physical interaction you have ever experienced is dictated entirely by these 3 hidden rules of particle engagement. When we manipulate these rules, we get the distinct states of matter. In a solid, the particles are tightly packed because their attractive forces are operating at maximum strength. They are vibrating aggressively in place, but they remain locked into a rigid geometric structure. If those attractive forces weaken to a moderate level, the structure breaks down. The particles gain slightly more space, allowing them to slide fluidly over and around one another while maintaining a cohesive group. This is a liquid, capable of flowing and adapting perfectly to its container. Strip away almost all of that attractive force, and the fluid grouping violently scatters. Now in a gaseous state, the particles move at random, high speeds, leaving massive empty voids between them. Because of this vast space, gases are highly compressible. Solid, liquid, and gas are not permanent identities of a material. They are merely temporary behavioral states, dictated entirely by particle spacing and movement. We can force matter to mutate between these states by applying external forces. Injecting heat increases the kinetic energy of a solid. The particles vibrate faster and faster until they overpower their forces of attraction, snapping their structural bonds and collapsing into a chaotic fluid swarm. Some materials bypass the middle step completely. If you heat crushed camphor, its particles skip the liquid phase and jump directly from a rigid solid structure into a chaotic gas. This direct leap is called sublimation. We can also trigger the exact opposite reaction using extreme physical pressure. By crushing a high-speed gas so tightly together that its empty space disappears, we force it to form a solid. This is how solid carbon dioxide, known as dry ice, is created. Temperature and pressure are the universal, invisible levers used by both humans and nature to force matter to change its behavior. But you don't always need extreme boiling to turn a liquid into a gas. Evaporation is a stealthy, continuous phenomenon. Rather than the entire liquid boiling at once, only the particles at the very top boundary layer detach and float upward, leaving the bottom mass undisturbed. To pull off this escape, these surface particles rely on a specific mechanism. They absorb the required kinetic energy directly from their surrounding environment, fueling their escape into the air. By absorbing and carrying away that heat energy, the escaping particles leave the remaining surface physically colder. This energy removal is the reason why sweat cools your body, or why a drop of acetone chills your skin. This microscopic behavior defines every physical object we touch. Our universe is built on particles constantly shifting, colliding, and reacting to the heat and pressure of the cosmos.